Those are the answers that are given in the book. In fact, the 62.5 actually had 67.5, but it was wrong, and I scratched it out and fixed it. So let's try to figure out what the actual question is that they're asking. Let's work it back. You know what? I do have a little squiggle there. It might be supposedly a negative. Well, let's look at the graph and let's look at what we think the question is. For figure 212, again, which one is that? It's the bike one, right? Okay. So find the cyclist speed and distance from where he started at 2 seconds. Okay, so if you go to 2, okay, so yeah, 10 meters and minus 15. So what should the question read? I'm going to make that change a little more noticeable in my book. What should the question read? Find the cyclist speed and distance from where he started. What does that from where he started even mean? What should it really say? I think it should be 2 questions. It should be find its displacement at 2 seconds and 7 seconds. Should it not? I think what they're trying to say there is distance from where he started. What does that mean? Distance from where he started? That means displacement, right? So find the displacement at 2 seconds and 7 seconds. If you want to make that change in your book for the next physics student, go right ahead. Find the displacement at 2 seconds and 7 seconds. Now, what about speed? Find the cyclist's speed at 2 seconds. Oh, hang on here. Hang on here. Slow down. Stop the presses. This is the velocity time graph. When you read the velocity time graph, what are we reading? We are reading speed. These first numbers should be 10 meters per second and meters per second. Should they not? We are reading speed. Yeah, you gotta get that out now. Pardon me? Did I read it the first time? Okay, good. I probably made the mistake when I transferred it here. Okay, so this is V-ints and V-ints. Okay, now let's talk about the displacement. Yeah, now I get it. Okay, so what is the displacement at 2 seconds? How do I find displacement at 2 seconds? You're looking at the area of the triangle plus the area of the rectangle, right? Nod with me. Yes, I get that. Okay, so from 0 to 2, base 1/2 base times height. 1/2 the base is 2, 1/2 the height is, 10. That's 10 meters. No. Mr. Bennett. What am I doing? Rectangle. Let's do the rectangle. Base times height. 2 times 10. Rectangle's 20. Triangle is base 1/2 of 2. Height of triangle is from 10 to 20 is also 10. 2 times 10 is 20. Half of that is 10. Total displacement, 30 meters. Please tell me that's what's in the back of the book. Yes, Emily? Oh, thank goodness. Now, here's where it gets stupid again. I remember this question from over and over and over. What is the displacement at 7? Is it 7? 7 seconds. Okay, so in other words, they want to know all of this area and then all of this area. Okay? How about you do that, and then we'll check back in about 2 minutes here. Try to find the area of those 2 triangles, compare it to the answer in the back, and then tell me if you think something's wonky. What's the area of the top triangle? The base is from 0 to 4, so that's 4. The height is 20. 40 meters, right? What's the area of the bottom triangle? 1/2 the base times the height. The basis from 4 to 7 is 3, and the height goes to, are we saying minus 15? So that's 45. Half of 45 is minus 22.5. Now here's where I have to have a big sigh. What's the back of the book say for an answer? 62.5, right? Actually, it originally said 67.5 was a mistake. Yes, and we fixed it. But the question is, are they talking about displacement? Because the question really says distance from where he started. They're kind of implying how far in total has he gone. So in other words, is the bottom graph negative? Not according to the answer in the back. What they really want to say is, to get that answer in the back, is how far has the bike gone? They don't care about displacement. How far has the bike gone? But they haven't really said that. Distance from where he... They've tried to put it all into one sentence, and they made a mess of having it. Right? So, if you want distance traveled, then the answer is 62.5. 40 plus 22.5. If you want displacement, well, then your answer is 40 minus 22.5, which is what? 17.5. In other words, the cyclist has traveled 62.5 meters vertically, has traveled vertically up and down a total of 62.5 meters, even though they've actually gone a farther distance, sort of. Their odometer on their bike would read greater. And they are, if you want to talk about displacement, they are 17.5 meters above where they were when they started, like a difference in altitude. It is a crazy question. I think it's good to see other people's mistakes. It is stupid. I agree. I also want you to experience how bad textbooks can be, because you're going to have exactly this type of situation come up in your future. You will get textbooks that have mistakes, and you're forced to try to figure out what the heck are they talking about. So what I've done there is I've sort of model it for you. Did I make some mistakes along the way? Yeah, but I've been through the slots, and I know what it's supposed to do at the end, right? At the end, I've given you what you need to know. I'm just showing you that textbooks are... Okay? So what I'm saying is, in your future, don't just go by what the answers in the back. You might have to sort of work things backwards, which is what I did here. Does that make sense? Okay. Now, in number two, this is what they want. 2 and 3 can be a little confusing. Let me do the first part of 2 and 3 just to get you started. Okay? Let's do the first one and number 2 together. Draw a representative VT graph showing uniform motion forward. So they want me to draw a VT graph of uniform motion forward. Uniform motion means constant velocity. So how do you draw constant velocity moving forward? Chris, I heard you say straight line. You mean straight, or do you mean straight and flat? You mean flat. Okay. You're correct. That is uniform motion forward. Okay. Now, jump down to question number 3. For the graphs in question 2, produce simple scales ranging from 0 to 5 seconds and 0 to 5 meters per second. Then calculate the following for each graph. So what they want you to do is they want you to put the numbers 0 to 5 seconds, and they want you to go from 0 to 5 meters per second. So everything is 5. The max is always 5. And they want to know acceleration, total displacement, average velocity for that graph. That's what they want in number 3. So in number 2, you draw the graph. In number 3, you put 0 to 5 and 0 to 5 on your axis, and then calculate those 3 things. Is that enough information going forward? No? I think I've told you what to do. Here's what I'm going to do. I'm going to give you the answers to 2 and 3 first thing tomorrow. So you've got a smidge of homework. Okay?